And welcome back. So we're going to take a look at an application of a double angle formula, but then that's going to quickly turn into a different direction. So don't be shocked if this video doesn't end up focusing on double angles. So suppose we want to find an exact value, the sine of, I don't know, pi by 8. Now if this was pi by 4, we wouldn't have a problem. But it's not pi by 4, it's pi by 8. Let's take a quick look at a diagram of this angle, because I always like drawing my angles. So sine of pi by 8 would be about right there. So this is the angle of pi by 8, and this is its sine. Now, wait a second. Pi by 8. If I just had two of these angles, I think I would come up with pi by 4. Which means there's probably a connection to my double angle formulas here. Now, if I wanted to know sine of pi by 8, I would need to know, oh, geez. Well, I suppose I could start with the sine double angle formula. So sine of 2x is equal to 2 sine x cosine x. Now, here's the thing. We're so used to seeing what we want on the left and what we have on the right when we deal with formulas. But in this case, we don't know what we have. We want, actually, this portion. Because if we consider x to be pi by 8, then this says sine of 2 times pi by 8, or sine of pi by 4, is equal to 2 times the sine of pi by 8 times the cosine of pi by 8. So we'll need to rearrange this formula somehow. But it becomes a problem because you'll have then, well, I guess a known, but you'll have an unknown here, the thing you're looking for, and you'll also have another unknown here. So instead of using the sine double angle formula to figure out sine of pi by 8, we're going to use the cosine one. And we're going to use the cosine one that contains sine. This is why it's kind of useful to have these things memorized, because you don't have to keep flipping back and forth. So cosine of pi by 4, because remember our x is going to be pi by 8, is equal to 1 minus 2 sine of pi by 8 squared. Great. Okay, let's rearrange this formula to go ahead and solve for sine of x, because remember sine of x or sine of pi by 8 is what we're looking for. I'm just going to swap some terms, so I'll move this term over and this term over. So this is going to leave me with 2 sine squared x is equal to 1 minus cosine 2x. And now I'll divide both sides by 2. And you'll notice as I'm doing this, I'm actually still generalized. I haven't substituted in my initial stimulus value of pi by 8. So when I end up at the end here, I'm going to end up with a formula that's going to allow me to find the sine of any half angle. In fact, this is the proof of a half angle identity. I've got one last step. I've got to do something. Oh, that's right. I've got to take the square root. But when I take the square root of both sides, I'll be left with sine of x. And just like in quadratics, when you take a square root, it creates two solutions. There's both a positive one and a negative one. Oh, I forgot to divide by 2. Shoot. See here? I should have divided by 2. Let's go ahead and divide by 2. There we go. So I'll have the square root of 1 minus cosine of 2x over 2. Now I was so focused on talking about this plus or minus that I ignored dividing by 2. But this plus or minus is interesting because how can there be two answers for sine of pi by 8? Because really, remember, we were going to use this to find the sine of pi by 8. So let's go ahead and find the sine of pi by 8. We'll fill in this formula here. This, by the way, is the half angle for sine identity, and that's how we go about doing its proof. We start with this rearranged version of the cosine double angle, and we work our way down solving for sine.